Hi all, this is our new project ARM based AI module for ectopic bit classification. So in this project, actually mainly we are doing classification of arrhythmia. So actually for arrhythmia, 5 classes are there: normal, unknown, ventricular, supraventricular and fusion. And that one we are mainly focusing using ECG. So nowadays in heart disease some issues are major concern for in our society. So by using this we can easily find any issues in our heart, like any beat issue or something. If anything is there means we can easily find it. So in here this one is the this one is the Raspberry Pi. So this one is the main processor. So along with this one is the ECG, and this one is the fault detection sensor, and this one is the SpO2 sensor. This one is the temperature sensor, and also this is the buzzer. So actually for in here, this one is the ECG. From ECG only we are classifying the arrhythmia. So in here it will take the electrical voltage and it will convert to peak. So in here we are taking 250 samples per second. So by using that one, 4 seconds we will continuously monitor, and it will the graph will plot. So at that time highest peak will come as the beat, and I think 4 or 5 beats it will take for 4 minutes. So that each bit we will plot again, and for that corresponding bit we will convert into spectrogram images. By using the CNN with the spectrogram image, we will predict which type of arrhythmia is there. So that one mainly using with the ECG. And other 3 sensors we are mainly used for like health status. We need to find it's abnormal or critical condition or normal condition. So for that in here this one is a SpO2 sensor. So in here SpO2 value, BPM will measure, and this one is the temperature sensor. From here temperature will measure, and this one is the extra one things fault detection sensor. Like any fault, if it is written means at that time the buzzer will turn on. So in here we put conditions as normal, abnormal and critical. For abnormal means if any, in here 3 parameters we are mainly taking: SpO2, BPM, temperature. Any of like if 2 are normal and 1 is come as abnormal means, so it will take as abnormal. And if the 3 values are like below threshold, like very less means, very less or very more means, it will take as a critical condition. So for this buzzer will turn on at the critical conditions only. So if any abnormal means, it will just print the warning and that and that. So after printing in here, we will send this data to the website by using API. So in output we will show in website, and also this one is the LCD. So in here also we will show the output. So now we will see the real-time working for this project. So this is the website for our project. So in here we can see that the project name in here, and also login, register, prediction, database is under the 4 buttons are here, and in here like logout and also about is there. So once in here first we need to create one account. So if I click means you need to add your name, email, like password, everything. So in here I already have one account. So if I log in here means you can see. So like this it will come. So in here arrhythmia detection and also health status, 2 buttons are there. So for arrhythmia in here we can see, so this one is the last value like we taken, so that one will come in here. So at that time we got this graph by using ECG. So at that time 4 beats are detected, and so in here this one is the beat 2, last beat, and the corresponding spectrogram will come in here. So by using this spectrogram it will predict it is ventricular or normal or supraventricular something, and by using that CNN model it is predicted as a ventricular. So this one is the health status. So now it is not connected because the value will not come. So they are like that this and finally this one is the database, like last data will store in here. Heart rate, SpO2, temperature, fault status, arrhythmial status. So this one is by use with timestamp it will come. So this and all the like normal introducing the database. Now we will see like real time value will come in here. So now in here the Raspberry Pi is connected with monitor. So this one is the Raspberry Pi interface. So in here this one our folder, and that one is there in here. This one is our final code, and this one is the CNN model. By using this one only it will predict the arrhythmia classification, and every plot images will be stored in here. So this one is the final code. So now I will connect this ECG in my body and we will see the output. So now the ECG is connected. So in here I will run this code. So now in here you can see the first it will connect the raw voltages. Then by using band pass filter the noises and it will cut and like good value will take. Now in here you can see the 5 beats. So this one is the first peak detection graph by using this graph. And in here these marks are the each beats. So for each beat it will print the spectrogram and it will predict it. So this one is the first peak graph and if I close means the beat 0 will come. So before that we saw like 1 X mark for each beat and this one is the first beat and corresponding say like spectrogram will come and in here it will predict it. So now in here you can see that beat is 0 is normal and the status API the data is entered and like in website also you can see the ECG that first plot and that beat 0 and the CVT like that corresponding spectrogram. So in here now this one is the next beat and this one is their corresponding CVT and in here it will predict it. This one also normally and that one also will send in here you can see. So this one is a beat one before we saw in here and corresponding CWT like spectrogram it will come and the A prediction also will come. So same like this every beat and corresponding CWT will send through the API. So this one is the beat 3 and the corresponding spectrogram will come. So now after that it will convert into the normal health cycle. Now the buzzer is turned on because of every parameters like BPM, SpO2, temperature is too slow because I didn't connect anything. So once if I place my finger on this SpO2 sensor, the value will take. So now the buzzer is turned off because the BPM, SpO2 and the temperature is taking. So now in here you can see that the BPM, SpO2 is normal, the temperature only the low. So that at that time the health parameters give us a warning like health parameters are normal and this one will send to the API. So in here you can see in health status like every time the value is changing like first heart rate is 68 now 98 oxygen saturation will come. So this one is a abnormal health because of the temperature is low. So if everything is low means it will come as a critical health. We will see that one. So now in here you can see that the critical health because of nothing is there. So like this is the working. Now we will see how the fall is detecting. So now we will see the fall detection how it will work. So this one is the MPU 6050. This one is the fall detection sensor. So suddenly if any movements come means it will detect it. So now I will move like this means. So in here you can see the fall is detected. So at that time in here also will come. So in LCD display also the values everything BPM, SpO2, temperature will measure and before that the arrhythmia that and all also will come in here. So this and all the all working for this project. Now it's completed. Thank you.